This week in artificial intelligence was not defined by one giant launch. It was defined by a pattern. Models are starting to move beyond answering questions. They are beginning to conduct research, operate software, use the internet, manage real workflows, and push into new physical infrastructure. Across 24 announcements, the same direction keeps appearing. AI is becoming less like a feature and more like an active layer across computing itself. The biggest story is OpenAI's claim that an internal version of its next major model produced 10 new results on long-standing open problems in mathematics and theoretical computer science. OpenAI says the work used roughly $2,000 worth of tokens at GPT-5-6 Sol API rates. That cost sounds high until you compare it with the economics of serious research. A difficult mathematical result can take months or years of expert time. A model that can explore large spaces of proof strategies, test ideas, reject dead ends, and surface promising arguments could change how research is organized. The key word is not solve. The key word is produce. If these results hold up under expert review, then the model did not merely retrieve knowledge or explain a known theorem. It contributed something new. That does not mean mathematicians disappear. It means their leverage could increase dramatically. Researchers would still need to verify the reasoning, formalize proofs, identify hidden assumptions, and decide which discoveries matter. But the search process could become much faster. One scientist could direct many model instances toward different hypotheses at once. One research group could evaluate thousands of candidate approaches instead of a handful. Even if most attempts fail, the cost of exploration drops. That is why this announcement matters more than another benchmark win. It points toward AI becoming part of the machinery that expands human knowledge. The second major OpenAI development is GPT-Live. OpenAI says GPT-Live can listen while it speaks, using a rebuilt voice architecture that keeps audio flowing continuously even while deeper reasoning and tools are running. That sounds like a small interface improvement until you think about how unnatural most voice systems still feel. Traditional voice assistants take turns. You speak, they stop, they process, they answer, and the conversation feels mechanical. Human conversation is overlapping, interruptible, and constantly adjusted by tone, timing, and context. A system that can keep listening while speaking changes the interaction model. You can interrupt it naturally. It can detect confusion before finishing a long answer. It can react while a tool is running instead of going silent. It can hold a more fluid conversation while still doing difficult work underneath. The important part is not that the voice sounds smoother. It is that reasoning, tools, and audio are no longer separate stages. They become one continuous loop. That brings AI closer to operating as a real-time collaborator instead of a voice menu. OpenAI also disclosed 2 incidents that occurred during external cybersecurity evaluations. The company says the activity was contained and that it is strengthening its approach to third-party testing. Anthropic highlighted a related report from the United Kingdom's AI Security Institute involving evaluations of Claude Mythos 5 and OpenAI's GPT-5-6 Sol in environments where normal safeguards were removed. These are not the flashiest announcements, but they may be among the most important. Frontier models are being given broader tool access, longer time horizons, and more autonomy. That means evaluation can no longer focus only on whether a model gives a bad answer in a chat. Evaluators need to test what happens when a model can plan, execute, persist, adapt, and interact with real systems. External testing is essential, but the testing process itself creates risk. The fact that incidents occurred does not automatically prove the models were out of control. It does prove that evaluation infrastructure now needs the same seriousness as production infrastructure. The laboratories are not just measuring intelligence anymore. They are learning how to contain capable agents during adversarial testing. That leads directly into the next major theme. Coding agents are becoming long-horizon software operators. Meta introduced Muse Code in beta, a terminal coding agent powered by its new Muse Spark 1.2 model. Meta says Muse Code is designed for complex, multi-file work across large repositories. It plans, implements, validates, and uses persistent subagents to solve parts of the larger task. The persistent subagent piece is the real signal. Today, most coding agents still behave like a very capable individual developer inside a loop. They inspect files, make edits, run tests, and continue. Persistent subagents move toward a different structure. One agent can own architecture, another can inspect tests, another can research a dependency, and another can validate the final result. The main agent becomes a manager of parallel work instead of the only worker. That is how large software projects are handled by human teams. The challenge is coordination. Subagents can duplicate work, make conflicting edits, misunderstand boundaries, or produce locally correct changes that break the larger system. If Meta has built reliable persistence, task ownership, and validation across a large repository, Muse code could represent a meaningful step beyond the current coding agent pattern. The value is not writing code faster. The value is maintaining coherence over a long sequence of decisions. Cursor's latest announcements reinforce the same shift from isolated coding tools to broader operating environments. Cursor says its agents can now read, write, and act across Google Workspace through plugins for Gmail, Drive, Calendar, Docs, and Sheets. That moves Cursor beyond the repository. A software agent can inspect a product brief in Drive, read customer feedback in Gmail, check deadlines in Calendar, update a planning document, modify the codebase, and write a summary back into the team's workspace. That is no longer just code generation. It is workflow execution across the systems where software work actually happens. The opportunity is obvious, but so is the risk. Once an agent can act across email, documents, calendars, and code, permissions become part of the product. A mistake in a code file is usually reversible. A mistaken email, deleted document, or altered calendar invite can affect other people immediately. The winners in this category will not be the agents with the longest feature lists. They will be the ones that make actions auditable, reversible, scoped, and easy to supervise. Google is pushing in the same direction with Gemini Spark and Chrome Auto Browse. Google says Gemini Spark can use logged-in accounts with permission to handle complex errands such as scheduling apartment viewings or researching flights. This is the consumer version of the same transition. Instead of helping you search, the model completes the process. That matters because the open web was designed for humans clicking through pages, not agents executing goals. Websites have different layouts, authentication flows, rate limits, pop-ups, forms, and hidden state. A strong browser agent needs perception, planning, memory, error recovery, and restraint. It must know when it has enough information to act and when it should ask the user. It also needs to survive websites changing underneath it. Brett Adcock's Hark Handoff is making an even more direct claim. The announcement says Handoff was independently verified as the best internet use model, outperforming ChatGPT 5.4 and Opus 4.8, with a focus on everyday tasks such as ordering food, booking flights, shopping, and navigating the web. The benchmark claim needs to be judged by the underlying evaluation, but the positioning is strategically smart. Coding agents receive enormous attention because software work is measurable and economically valuable. Everyday internet use is a much larger surface. If an agent can reliably complete real consumer tasks, it becomes useful to almost everyone, not only developers. The difficulty is that failure is more personal. A bad code patch can be reverted. A wrong flight booking, accidental purchase, or incorrect food order costs real money and creates real friction. Internet use agents will succeed only when they combine competence with confirmation, transaction limits, and clear receipts. Liquid AI is approaching agency from the opposite direction, smaller, local, and private. It released LFM2526B, an agentic model designed to run entirely on device. The company says it can plan, call tools, and complete multi-step tasks across phones, laptops, personal computers, and robots while keeping data on the device and making the marginal cost of each run effectively zero. This is a major counterweight to the cloud agent trend. Frontier cloud models can be more capable, but local models offer privacy, low latency, offline operation, and predictable cost. A 2.6 billion parameter model will not replace the largest systems for every task. It does not need to. It can become the always available layer that handles routine actions locally and calls a larger model only when necessary. The strongest future architecture may not be one model. It may be a hierarchy. A small local agent for constant interaction, a larger cloud model for difficult reasoning, and specialized tools for execution. Technium's Hermes agent release points toward that kind of modular ecosystem. The update includes voice-activated chats, plugins, a Kanban interface, an agent-to-agent protocol, outbound webhooks, and performance improvements. Each feature matters less individually than the combination. Voice gives the agent a natural interface. Plugins expand its abilities. Kanban gives work visible structure. Agent-to-agent communication enables specialization. Webhooks let the system trigger actions outside itself. This is how agents start becoming platforms. A useful agent is not only a model with a prompt. It is a control system that receives goals, breaks work into tasks, delegates, tracks state, communicates with external services, and reports completion. The model is central, but the surrounding harness determines whether the system is dependable. The hardware layer is changing just as quickly. NVIDIA says SpaceX's Starmind AI-1 satellite compute payload is powered by NVIDIA Vera Rubin NVL72, bringing AI factory compute into orbit. The announcement is dramatic, but the deeper question is why put AI compute in space at all? Satellites already generate enormous amounts of data from imaging, communications, weather, navigation, and scientific instruments. Sending all raw data back to Earth creates bandwidth limits and delay. More capable compute on the satellite allows data to be processed before transmission. The system can identify useful information, compress it intelligently, detect anomalies, and make decisions closer to where the data is created. Orbital compute also introduces severe constraints. Power is limited. Cooling is difficult. Radiation affects hardware. Repairs are expensive or impossible. Reliability matters more than peak benchmark performance. If high-end AI systems can operate under those conditions, it opens a new infrastructure category. The data center does not disappear, but intelligence becomes more distributed across Earth, devices, robots, vehicles, and space-based systems. Cursor's other announcement is much deeper in the stack. The company is open-sourcing Mixture of Kittens, or MoK, a mixture of experts training megakernel for NVL72 systems. Cursor claims it combines communication and computation into one deterministic kernel and runs up to 2.37 times faster than the strongest public baselines. This type of work does not attract the same attention as a new chatbot, but it can have enormous leverage. Training large mixture of experts models requires moving data between specialized expert components. Communication overhead can waste expensive hardware time. A faster fused kernel means more useful training work per dollar, faster experiments, and potentially larger or more efficient models. The deterministic part also matters because reproducibility helps engineers debug and compare training runs. Model progress is not only about new architectures. It is also about making the entire compute stack waste less time. A comment from Thibault captures the mood around this infrastructure shift. He argues that Codex is a good harness today, but may look primitive within 2 or 3 months, because the next generation of frontier model use will require more than a laptop. That prediction may be aggressive, but the direction is plausible. Current agents are often constrained by one local machine, one context window, and one sequential tool loop. The next generation may operate across remote sandboxes, persistent memory, large repositories, multiple specialized agents, browser sessions, and scalable compute. The interface may still look like a terminal, but the system behind it could resemble a small cloud organization. The competitive advantage will come from orchestration, not merely model access. Now to the model competition itself. Arena. AI says Opus 5 Max reached number 1 in the full-stack code arena with a score of 1,699. The leaderboard evaluates full-stack web development across multi-step reasoning, tool use, and end-to-end application generation. Leaderboard positions move, and no single benchmark captures real production performance. Still, full-stack evaluation is more informative than isolated code completion because it tests whether the model can carry a product through multiple stages. It must interpret requirements, choose an architecture, create files, connect components, debug failures, and produce something usable. A model can be brilliant at one-off functions and still fail at system-level work. Reaching the top of this kind of arena suggests strength in sustained execution, although developers should still care about reliability, cost, speed, and how often the model needs rescue. QN3, 8 Max also reached number 2 in the image-to-web dev arena. This category asks a model to look at a visual reference and reconstruct it as a functioning web experience. That combines perception, design interpretation, layout reasoning, and code generation. Image-to-web development is becoming one of the most practical measures of multimodal competence. The model must notice spacing, hierarchy, typography, component relationships, and responsive structure. It cannot succeed by recognizing objects alone. It must translate visual intent into a working implementation. Strong performance here means the gap between a design reference and production code continues to shrink. QN also reported that QN Image 3, 0 Pro reached number 5 globally in image generation rankings, describing it as a major leap over the previous generation. Taken together, the two QN announcements show a broader strategy. One model family generates and understands visuals, while another converts visuals into interactive software. That creates a loop where AI can ideate a design, render it, inspect it, build it, and revise it. The boundaries between designer, image model, and coding agent are becoming less rigid. Minimax announced that Minimax H3 is now publicly available. The announcement itself is brief, so the significance depends on access, pricing, capability, and how developers adopt it. But every strong public release increases competitive pressure on the frontier labs. Model markets do not move only when a company takes first place. They move when capable alternatives become available, cheaper, easier to deploy, or better suited to a specific region and workflow. The creative AI category is advancing just as quickly. Black Forest Labs launched Flux 3 Video with native audio, text-to-video, image-to-video using multiple frames, video continuation, multilingual dialogue, and a draft mode for faster, cheaper iteration. Native audio is one of the biggest parts of that package. Early video models produced silent clips, forcing creators to build speech, ambience, sound effects, and music separately. A model that generates synchronized visuals and audio can maintain continuity across the entire scene. Multi-frame conditioning also gives creators more control over where a shot starts, where it ends, and how identities or objects persist. Video continuation addresses one of the hardest practical problems: extending a good clip without losing the scene. Draft mode may be the most commercially important feature. Creative work requires iteration. A beautiful generation is not useful if every experiment is slow and expensive. Cheap drafts let creators test ideas, camera movement, dialogue, and composition before committing to a high-quality render. That makes the workflow more like professional production and less like buying a lottery ticket. Higgsfield is showing what long-form use can look like. The company open-sourced the prompts and assets behind Hell Grind, a 95-minute AI feature film reportedly made for $500,000 and screened at Cannes Market. Whether the film is artistically successful is separate from the production signal. A feature-length project forces AI tools to confront continuity, character identity, pacing, editing, sound, shot selection, and narrative coherence. Short clips can hide inconsistency. 95 minutes cannot. By releasing the prompts and assets, Higgsfield gives other creators a chance to inspect the workflow instead of seeing only the final marketing reel. The $500,000 budget also provides a useful reality check. AI film production is not yet free. It can reduce or redistribute costs, but serious long-form work still requires direction, iteration, labor, and infrastructure. Kimi is applying the same end-to-end idea to presentations. Kimi work can research a topic, create a clear structure, design polished charts and smart art-style visuals, and deliver an editable slide deck. Slides are a strong agentic task because the output must satisfy several disciplines at once. Research must be accurate, the narrative must flow, the design must remain consistent, charts must support the argument, and the final file must stay editable. A system that only writes bullets is not enough. A system that creates beautiful slides with weak reasoning is also not enough. The winning product must combine research, synthesis, visual judgment, and document engineering. Gemini Notebook is expanding access to its more powerful notebook experience, with the announcement saying the rollout is complete for pro users and that free users also receive access to parts of the experience. Notebook tools matter because they ground the model in a user's own source material. Instead of asking a general chatbot to know everything, the user provides documents and asks the system to analyze, connect, teach, or transform them. That model is especially useful for learning, research, legal review, business analysis, and any workflow where source fidelity matters. The more capable notebook experience also reflects a larger product shift. The future of AI may not be one empty chat box. It may be specialized workspaces built around a collection of sources, persistent projects, and repeatable outputs. Cloudflare introduced Cloudflare Wallets, designed to store stablecoins, purchase services, and receive funds across the web. This may look separate from the AI story, but it fits directly into the agent economy. Agents can already browse, compare products, call APIs, and perform work. The next step is economic agency, paying for services, receiving funds, and settling transactions. Stablecoin wallets provide a machine-friendly payment layer that can operate globally and programmatically. The opportunity is enormous, but the risk is obvious. An agent with spending authority needs strict limits, identity controls, fraud protection, transaction receipts, and clear human override. The important question is not whether an AI can hold money. It is whether the permission system around that money is safe enough to trust. The final two announcements show another part of the ecosystem: AI companies supporting open-source infrastructure. Several FFmpeg developers received 6 months of the Claude Max 20 times plan through Anthropic's Claude for Open Source program. FFmpeg says Claude has already helped identify missing backports for the upcoming version 9 release. Cursor also provided free credits to several FFmpeg developers for development and code review. FFmpeg sits underneath an enormous portion of the modern media stack. Video platforms, editing tools, streaming systems, browsers, and AI media pipelines all depend on it. Supporting maintainers of foundational open-source software is not charity in the narrow sense. It strengthens infrastructure that the entire industry relies on. There is also a feedback loop. Open-source maintainers use AI tools on difficult real repositories. Their failures expose weaknesses in code understanding, dependency reasoning, testing, and review. Their successes provide evidence that agents can contribute to mature systems where mistakes matter. The tools help the project, and the project becomes a proving ground for the tools. Taken together, these 24 developments point toward one conclusion: AI is leaving the single model era. The important unit is no longer just the model. It is the model plus the harness, the tools, the permissions, the memory, the compute, the interfaces, the payment layer, and the systems used to validate its work. OpenAI's research result points toward models contributing new knowledge. GPT-Live points toward continuous human interaction. Meta, Cursor, Google, Hark, Liquid AI, and Hermes point toward agents operating across software and the web. NVIDIA and Cursor's kernel work point toward intelligence spreading across new infrastructure. QN, Opus, and Minimax show the model market remaining fiercely competitive. Flux, Higgsfield, Kimi, and Gemini Notebook show AI moving deeper into creative and knowledge work. Cloudflare's wallet announcement points toward agents eventually participating in economic systems. The most important question is no longer whether AI will become more capable. It clearly will. The question is whether the surrounding systems become reliable fast enough to convert capability into useful work without creating unacceptable risk. That is where the next major competition will happen, not only in intelligence but in orchestration, not only in generation but in verification, not only in access but in control. And based on this week's announcements, that competition is already underway.